Thank you very much to Jean Carlock for your invitation and for your kind introduction and to the members of the organizing committee. Once again, I would like to thank you for allowing me to return to this beautiful city, and Professor Cumby, I would like to attend. Thank you very much for your molecular and cellular interventions that increase recovery. This is like a sketch, just talking about the principles of achieving this strategy. And also looking at the goals. What are the precursor cells of oligodendrocytes? Demyelination quotient migration and OPCSY blockers, oligodendrocyte precursor cells, astrogliosis microglia and those that prevent their migration, oligodendrocyte precursor cells and microglia desmyelination, as well as changes in the hostile immune inflammatory environment. And we're going to show 2 cases, apixabanumab and clemastine, and then we're gonna finish. I had already shown you this slide. As Jean Carlos has told us, we need to intervene in all the agents that affect the immune system in this therapeutic area. Structural integrity or damage caused by this immune system, which increases the function of recovery. So here, unfortunately, we don't have these points available yet, so myelination is very important. As you know, axons are exposed and susceptible to the magnitude of the mediator's harmful actions, and it is also of the utmost importance. Remyelinize these axons because if they don't eventually die, there's no way they can recover. Therefore, neurobiology has shown us how oligodendrocytes and precursor cells differentiate into oligodendrocytes, and this is related by deploying different targets that are both activators and inhibitors. As shown on the right and top, we can see what happens to these lesions, where they need to be, oligodendrocyte precursor cells. They become resident or reduced oligodendrocytes, which show us the signal that this is so that these guide cells can be myelinated. Another very important point is that without refactoring, it is presented in. Therefore, maintaining the immune process is a fundamental need because otherwise the newly degenerated axons must act on the immune. Again, here on the right hand, we can see a sample of targets that have been clinically identified as a target that can be modulated. We have established the ability to differentiate them into fully remyelinated oligodendrocytes. I think it's a very interesting approach. This is based on animal studies that show that organisms with oligodendrocytes fail to respond to differentiation signals. OPCSO is an oligodendrocyte precursor cell. They acquire many points of cell maturity or age. In addition, for example, metformin mimics are rejuvenated due to poor remyelinization and aging. Metformin shows us age-related changes. In reverse, OPCs can respond to different differentiation factors. As we all know, metformin is a drug for anti-diabetic patients, and its safety profile has been established, so it is only representative of the market. Of those currently used for re-engineering, a number of tests are already being carried out to maximize the test. For example, on the left-hand side, we can see the design of the trial and the main results. With secondary SMS, MRI, all these measurements that we can see and capture what we can really use as clinical and imaging tools to evaluate. Potential effects of remyelination? Well, I've been talking to you again about these effects and how we need to investigate what they are perfectly potential and how we can do a complete analysis and search for these molecules. For example, as you remember, this is an important trial developed on these pillars. If the effects of these potentially interesting drugs are examined and carried out, then basically 2030. Potentially interesting compounds available that can be studied for remyelinization. Now I'd like to briefly talk about, say, the early theories and attempts. If you study these points, you can develop these points to remelinate these points in opsilimab. These specific membranes associated with proteins that hinder remelination, approaches and models of myelitis encephalopathy of the right hand. We can see that the severity is very important for modeling, and it has been reduced with these antibodies. But you can also see here on the left, this anti-LINGO treatment promotes remelting and repair in this experimental multiple sclerosis model. These preclinical data led to the development of the first clinical development program for the treatment of acute optic neuritis with Opus Synhab remelting strategy, and the synergy study in a targeted population of recurrent patients. The Infinity study. Now I don't want to go into too many details. The executive summary has interesting clues to the remyelinating effect of Opus Synovith. These are the main unfulfilled outcomes. Now, in a randomized controlled study or PAS, Zynovat has recovered P100 of the delayed incubation period of visual evoked potentials. The SNERGY study was conducted in a placebo-controlled M with multiple component evaluation criteria. In the lower right part of this study, 80% of patients with recurrent and secondary progressive MS were included, all of whom were active in the previous months, whether virgin or treated with disease-modifying therapy, and did not meet the primary and secondary evaluation criteria, but the patients improved. On the left, we see a post-hoc analysis that identifies a subpopulation that has benefited from treatment evaluated by this multi-component evaluation criterion. So now, these are the results and questionnaires are being applied. Now the second very promising result is the first generation of antihistamines, the muscarinic receptor clemastine, which has been used for many years for anti-allergies. This is a job. From Ari Green's group in San Francisco, who used the above-mentioned pathway paradigm to study potential defects. And this is a crossover study. Patients were given climazine as the first treatment or placebo and then change. What you can see here is the special latency. And the orange line shows patients who received placebo for the first 3 months. Delayed P100 remained basically stable, and then if we switched to clemastine, there was a significant recovery in P100. Delayed P100 respond vice versa if we started with clemastine. We soon saw a positive effect, which lasted until we switched to placebo. Clemastine also improved the clarity of low contrast letters. Now, Professor Ontanera gave us a very good outline. From the possibility of remelting with imaging, he introduced the concept of water in myelin, the water fraction in myelin, which was applied in this study by Green Lab N. Only to repeat the water fraction decreased in if it was correlated with disability. So what they observed and could see was the 2 time intervals and the patients were randomized. First with clemastine there was an increase, you can see. The color changes in percentage and the myelin sheath water in the callus with clemastine is reduced. In contrast, if no treatment is applied, there will be no positive effect. This is another very interesting study. The Sydney team, led by Michael Panett, used a very interesting nanocatalytic compound, which is nanocrystalline, acetated and clean gold, and it showed that it improved remelting and stimulated it. Evaluate this approach in patients using visual pathways to see the impact on deficits. This is chronic optic neuropathy. The study was called Visionary MSY. The latest results are presented in at one meeting was a 49-week, phase 2 placebo-controlled study. He was given 3,030 milligrams of gold nanoparticle, and we saw how the contrast letters changed in sharpness. Low contrast, and the secondary was the functional composite scale. Recurrent and progressive QM patients with acute chronic neuropathy were recruited. Unfortunately, not all the population was able to recruit. This is a study that took place during the pandemic. So we didn't get the entire planned population for questioning. What you can see here is that the primary effect, that is, the change in the sharpness of low contrast letters, has a positive impact on this intervention. Similarly, side effects or aggregation showed placebo superiority in this study over placebo, and we also saw periclinic evidence. For myelin and axonal integrity, multifocal visual evoked potentials, diffusion tensor imaging and magnetization transfer imaging and in medium. This reflects the integrity of the myelin, and as you can see, compared with placebo, gold nanoparticles have a positive effect. And if they see fractional anisotropy, that is, axonal integrity, this is a positive effect in several brain regions they treat. Gold nanocrystals, so we need to see if it's possible to develop this further into phase 3. I'm not sure how to develop a brief discussion of the modulator of the S1PR receptor, at least preclinically proven. The properties of repair promoters are mainly mediated by S1PR. Together with the Paris group, we have seen potential prelionizing activity of siponimor with microglia, as Professor Comic's target, have already emphasized the potential role of microglia. Here we study several models, such as the transgenic MOOCEA. Here is that if PonyMod's version. These three myelinated models also increase the number of myelinated axons, and you can also see this from the electron microscope. On the right is a microglia phenotype scan. As you know, they come in different forms. And the simplistic version is that there is a pro-inflammatory phenotype M1 and two phenotypes, anti-inflammatory, and there are molecules that identify them. And on the right, you can see, for example, TMF as a marker in 1 phenotype. It was less exposed to NAMOD EAE, the microglia phenotype. Homeostatic phenotypes and living molecules are identified, and the results are consistent. Now I'm not going to talk about this again. This is a very important study. It's a progenitor cell study. On the left you can see these cells are defective, heterologous transplanted and differentiated into various glial cell populations. So this is a very good example of translating preclinical knowledge into application. In this phase 1 open study called CEO as a small group, it was a pilot study, 12 patients with progressive MS, and as Giancarlo has already said, the primary results. Security was good, there were no problems there, and something very interesting is that there was an effect in terms of brain volume loss, which decreased, and interestingly, it decreased relative to the number of intrathecal neural precursor cells, so there was a higher CSF level. And neuroprotective and anti-inflammatory molecules, so this will guide us to further examine the role of progenitor cells in different versions, so to speak, in a repairing approach. And finally, taking back what the professor said with why we must change. The adverse inflammatory microenvironment overcomes the effect of remyelinization. Now I'm not going to go into detail. We all know the key role of B cells in the peripheral, especially in the central nervous system. And how do they interact with microglia and T cells? This is critical to promoting the progressive chronic phase of multiple sclerosis. And so remyelination has a subtle effect and protects the axons. It is important to have a sustained immune response. Well, we've already talked about microglia and different phenotypes, so we need to create a less gun-free immune microenvironment. It also means pushing microglia toward homeostatic, anti-inflammatory phenotypes. This was an experimental work with a Nemoto guy that I already showed you. Giancarlo has also shown the key role of microglia. Will there be a next study to promote remelting and purifying myelin remnants in various ways and allow them to migrate to molecular networks in, of course, BTK inhibitors? And they were effective. This is a study by the Paris group. Then we obtained organotypic brain cultures, and when compared left and right, this immunofluorescence study showed that the BTK individuals restored the ordered structure of the ganglion. Well, so maybe BTK inhibitors could be used as a means to promote remelization. Finally, among the many advances, I would like to briefly introduce the Phase 2 study of oxygen rewrap. Doptepan vase is a selective estrogen modulator. It protects bone mineral density, and EMA has been tested for postmenopausal use. In this study, the primary outcome was secondary outcome was low contrast visual acuity in OCPR water fraction and RNFLY. Based on the knowledge accumulated over a decade and the role of thyroid hormones in promoting remyelinization, this Phase 1b open-label study of leothyroxine has been conceived and has begun in individuals with multiple sclerosis, and we hope that this drug so sure will give us evidence. A reparation for motion activity. So let me jump to my conclusions. There are a range of potentially effective interventions, both exogenous and endogenous, that have been explored or are currently being explored. We still need to identify appropriate results of clinical studies, whether clinical, imaging, MRI, PET, evoked potential coheromorphography, and access to demyelinating lesions are important and we must be aware of. There is a critical window of opportunity. When the interventions work, we're out of that window. Axons are doomed to die whatever we do. As I mentioned, we need to have a continuous inflammation cancellation. And with this, I want to remind you of the next one. Thank you to my colleagues at the SB meeting, and I would like to thank you for your attention.